Welcome to ScienceCover.com. In this session, we will look at wave terms and equations. We'll look at wave terminology, how we can draw waves, how we calculate the frequency and the time period, and how we can work out the wave speed. Let's begin by pausing the video and completing the Do Now task. Let's check our answers to the Do Now task. Number 1, what do waves transport? Energy. Number 2, what do waves not transport? Matter. Number 3, what is a transverse wave? This is a wave whose vibrations or oscillations are at a right angle to the direction that the wave is traveling. Number 4, what is a longitudinal wave? This is a wave whose vibrations are in the same direction to the direction that the wave is traveling. Number 5, give an example of a transverse wave. We could say a light wave, microwave, radio wave, infrared light, ultraviolet waves, gamma rays, X-rays, water waves, or S waves. Number 6, give an example of a longitudinal wave. Sound waves and P waves. Let's now familiarize ourselves with some of the terms used when we discuss waves. We can represent both a longitudinal and a transverse wave by drawing a crest and a trough either side of a zero axis. This pattern then repeats. The peak is the highest point of the wave, and the trough is the lowest point of the wave. We can calculate the wavelength of a wave by taking two peaks and working out the distance between them. The length between these 2 points is known as the wavelength. We can also calculate the amplitude of the wave. This is the size of the wave from the 0 point to its maximum height. To represent amplitude, we use the symbol A, and we can define amplitude as the distance from the center to the peak of the wave, and we measure it in meters. The wavelength is represented by the symbol lambda. This is the length from one peak to the next peak, and again we measure it in meters. The frequency of a wave is represented by the letter F. This is the number of waves produced in 1 second, and we measure it in hertz. The time period is represented by a capital T, and this is how long it takes to create one wave. We measure this in seconds. Pause the video now and complete task 1. Let's check our answers. The symbol for amplitude is a capital A, and the meaning is the distance from the center to the peak of the wave. The length from one peak to the next is a description of the wavelength, and the symbol is a lambda. The symbol little f stands for frequency. This is the number of waves produced in 1 second. And the time period is represented by a capital T. This is how long it takes to create one wave. In question 2, a child created a guitar using different width elastic bands and an old shoebox. The child then plucks the elastic bands and watches the waves it creates as it vibrates. Explain how the child can increase the amplitude of the waves. They can pluck the elastic bands with more force. How will increasing the amplitude change what is heard? The sound will become louder. Plucking the thinner elastic bands increases the frequency of the waves. How will this change the pitch of what the child hears? It will create a higher pitched sound. What difference will the child see in the motion of the thin elastic band compared to the thicker elastic band? It will vibrate at a faster speed. Let's now look at how to draw waves. We can draw waves a few different ways. This wave diagram on the screen now uses time on the x-axis and the distance of the particle from a central point on the y-axis. This type of diagram acts as a distance time graph, showing us how a particle moves forward or backward or up and down as time passes. But we could also draw a displacement distance graph. Here we can see distance on the x-axis and displacement on the y-axis. Now this graph shows the position of many particles over a length of string or an elastic band, and it shows how the particles are displaced from the center by different amounts at different points along the length. This distance displacement graph shows the displacement of a guitar string just after it has been plucked. We can see distance is plotted on the x-axis, and the displacement of the string is plotted on the y-axis. As we move along the string from left to right, we can see that the displacement or position of the string changes. There are points where it is positive above the 0 mark and places where it is negative below the 0 mark. The amplitude is marked out by the green arrow, and we can measure this from the central 0 line to the peak of the wave. The wavelength is marked by the red arrow. We can see that this travels from one peak to the next peak. Pause the video now and complete task 2. Let's check our answers. Sketch a distance time graph to show the motion of the pendulum. The pendulum has a time period of 40 seconds, so one wave should take 40 seconds to create. We know that we have a maximum displacement of 1 meter, so we should see a peak at 1 meter and a trough at -1 meter. Add the labels to the wave at the correct locations. You can see the positions of the labels on the screen now. Now let's look at how we can calculate the frequency and the time period. The frequency is how many waves are produced in 1 second. The time period is how long it takes to make one wave. So we can find the time period by dividing 1 second by the frequency. We can write this as an equation. The wave period, or the time period, equals 1 divided by the frequency, or t equals 1 divided by f. We can place these values into an equation triangle to help us rearrange the equation. So the 1 goes on the top of the triangle, and the f and the t go on the bottom of the triangle. Now if we cover up the 1, it tells us that f times t should equal 1. So the frequency of a wave multiplied by the time period of that wave should always equal 1. The time period can be calculated by dividing the number 1 by the frequency of the wave. And the frequency of the wave can be calculated by dividing the number 1 by the time period. Let's look at an example. A speaker cone vibrates 2,000 times in 1 second. How long will it take to produce one wave? Well, the frequency of the cone is 2,000 Hz, as it's producing 2,000 waves in 1 second. So to calculate how long it takes to produce one wave, I need to find the time period. The time period is 1 divided by the frequency. So this is 1 divided by 2,000. 1 divided by 2,000 gives me 0.0005. So it takes 0.0005 seconds to produce one wave. Let's look at a second example. A bird flaps its wings. Each flap is complete in 0.1 seconds. What is the frequency of the sound produced by the bird's wings? Well, if each flap is complete in 0.1 seconds, then it means that the time period for the waves must be 0.1 seconds. The frequency of the sound can be found by dividing the number 1 by the time period. So the frequency is equal to 1 divided by 0.1. 1 divided by 0.1 gives us 10. So the frequency of the bird's wings is 10 Hz. This is below the human hearing range. Pause the video now and complete task 3. Let's check our answers. Number 1. What equation relates frequency and time period? The frequency equals 1 divided by the time period, or the time period equals 1 divided by the frequency. What are the units of frequency? It says Hertz. What are the units of time period? Seconds. A speaker is vibrating once a second. What is the frequency of waves produced by the speaker? That'll be 1 Hertz. The frequency is increased to 200 Hertz. How many times does the speaker vibrate per second? 200 times. What is the time period of the speaker? To find the time period, we do 1 divided by the frequency. So 1 divided by 200, which equals 0.005 seconds. Question 2. The missing values are 0.2 seconds, 0.01 seconds, 0.017 seconds, 0.05 Hz, 0.025 Hz, 0.33 seconds, and 10 Hz. Let's now look at how to calculate the wave speed. The speed at which a wave travels is related to its frequency and its wavelength. Wave speed can be found by multiplying the frequency in Hertz by the wavelength in meters. We can place this equation into an equation triangle with velocity at the top of the triangle and frequency and wavelength at the bottom. To find the velocity, we can see that we need to multiply the frequency by the wavelength. But if we wish to find the frequency, then we need to take the velocity and divide it by the wavelength. If we want to find the wavelength, then we can take the velocity and divide it by the frequency. Let's look at an example. A sound wave has a wavelength of 0.033 meters and a frequency of 10,000 Hz. What is the speed of sound? So to find the speed or velocity, we must multiply the frequency by the wavelength. So this is 10,000 Hz multiplied by 0.033 meters. So the speed of the wave is 330 meters per second. In this example, a wave is moving at 10 meters per second and has a wavelength of 0.2 meters. What is the frequency? So the frequency can be found by taking the wave speed and dividing it by the wavelength. The wave speed is 10 meters per second and the wavelength is 0.2 meters. So 10 divided by 0.2 gives me 50 Hz. Pause the video now and complete task 4. Let's check our answers. What equation relates frequency, wavelength, and wave speed? The wave speed in meters per second is equal to the wavelength in meters multiplied by the frequency in Hertz. For question 2, we have to calculate the speed of the wave. For A, this is 100 meters per second. For B, it's 100 meters per second. And for C, it's 300 million meters per second. Question 3, we have to complete the table. The missing wave speed is 20 meters per second. The second missing wave speed is 9 meters per second. The third missing value is a wavelength of 0.66 meters. The fourth missing value is a frequency of 0.2 Hz. The fifth missing value is a wavelength of 15 meters. The sixth missing value is a frequency of 5 Hz. And the seventh missing value is a wavelength of 0.4 meters.